The second part of lesson 8.5, add and subtract with unlike denominators. Notice there are a lot of steps here, so let's pay attention to the detail with the order. The first thing you want to do is actually just factor the denominators. We don't want to do top and bottoms, just the denominators. And then we'll state our restrictions. So we know that we've done all that before. And then the tricky part, whoops, I don't know where that came from. Sorry. Then the tricky part, finding that least common denominator. Taking a look at all numbers, monomials, and then binomials. So we're going to have to try to figure out what could we make all of these unique denominators look like to have a common denominator. And then we convert each fraction. So this is a tricky part. Once you have common denominators, we combine the numerators, which you would do with any adding and subtracting of fractions. Then whatever is left over in that numerator, we're going to factor it if possible. Make sure that if you have anything that's being added or subtracted, that we put that in parentheses in order to not reduce part of that sum or difference with something that was in a parenthesis. And then if possible, we'll reduce our final answer. And we'll always keep our answers in fraction form. All right, let's try a couple. Find each sum. 3 over 4x plus x over x plus 2. Step 1, factor the denominators. Well, we have a 4x, which is just one term, and then an x plus 2. I'm going to put that in parentheses. So there are no common factors or anything that we can take out of the denominators. So they're already factored for us. Step 2, we'll state our restrictions for our domain. In that first fraction, we have 4x. So if we say 4x can't equal 0, and we divide by 4, that just means, whoops, sorry, cross that off, x can't equal 0. That's one of our restrictions. And then if we say x plus 2 can't equal 0, then x can't equal negative 2. So there are our two restrictions for our domain. All right, step 3, find that least common denominator. So our LCD. Take a look at that first fraction. We've got a 4, which would be just a number, and then an x, which would be the monomial. That means we're going to need to include that in our least common denominator. And then we have the x plus 2 in parentheses. So any binomial x plus 2 or anything with addition or subtraction has to be considered a unique term. Like the x in the x plus 2 doesn't match up with the x in the 4x. They're different parts. This means our least common denominator is simply the product of both of those terms. So, step 3, let's see how we do this conversion. I'm going to write 3, and then I'm going to do a long fraction bar over 4x. And then I'll do plus, and I'll do the same thing for that second fraction, x over x plus 2. So here's what I mean about converting each fraction. In that first fraction, we have the 4x, but it's missing the x plus 2. If I put that on the bottom to give it the least common denominator, we have to also put that on the top. So it's just like changing a fraction, not changing what it means, but just changing what it looks like. In that second fraction, it had the x plus 2, but it's missing the 4x. So if I put 4x on the bottom, I need to put 4x on the top. And that's kind of converting each fraction. From here, what we'll do is we'll simplify the numerator by distributing the 3 in, and that would give us 3x plus 6, and then plus x times 4x is 4x squared, all over our LCD of 4x times x plus 2. What I'm going to do in the numerator is just rewrite it in standard form. I'm going to put the 4x squared term first. 4x squared plus 3x plus 6 all over 4x times x plus 2. So if we try to factor the numerator, we're going to have to do a times c split to get b. A times c is 24. Now it needs to be positive 24. So if we think of all the numbers that go into 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, there's actually no way to get 3 in the middle. That means it's not factorable. If it's not factorable, it has to go in a parenthesis as the entire thing. And the only time you could cancel out the top part is if you had a matching exact denominator in the bottom. And we don't have that. Notice we have 4x squared plus 3x plus 6 on the top divided by 4x times x plus 2. Now be careful, the 4x and the 4x squared do not, and I repeat, do not cancel out. What ends up happening here is this is as far as we can go. We combine the like terms in the numerator, we have our restrictions in our domain, and there's adding those two fractions together. Our next example has x plus 3 over x squared minus 1 plus 2 over x squared minus 3x plus 2. So the first thing we need to do is factor the denominators. In that first denominator, we have x squared minus 1, and those are both perfect squares. So that would give us x plus 3 over x plus 1 and x minus 1. And you can write those in either order. X squared minus 3x plus 2. What are two numbers that would multiply to get positive 2 but add to get negative 3? We would have x minus 1 and x minus 2. They multiply to be positive 2, but they add to get negative 3 in the middle. All right, let's state our domain. We know if x plus 1 can't equal 0, x can't equal negative 1. X minus 1 can't equal 0, x can't equal positive 1. We have another x minus 1, so we don't have to repeat that. We'll go to the x minus 2. If that can't equal 0, then x can't equal positive 2. And there's our domain restriction. Those need to be included with our final answer. Then the next step, state the least common denominator. Notice we only have binomials. We just have groups of parentheses. I see an x plus 1 in one of the fractions, so that has to be included. Notice the x minus 1 is in both of them, but we only include it once. Since it already has it, we don't have to double up in each of the denominators, because then it wouldn't be the least common denominator, and we'd have more parts to try to simplify in the numerator. And then last but not least, there's that x minus 2 in that second fraction that we would need to include for our least common denominator. Once we know what we want for that LCD, the next step is to convert each fraction. This is step 4. So I'm going to take that x plus 3 and put it in parentheses. Probably could have put it right there too, I suppose. So if I have x plus 3 over x plus 1 and x minus 1, the term that it's missing for the LCD is x minus 2. If I put that on the bottom, I have to put that on the top, which means we're going to have to FOIL this. But we'll do that in the next step. All right, and then we have plus 2 over x minus 1 and x minus 2. It has 2 of the 3 parentheses, but it's missing the x plus 1. If you put that on the bottom, go ahead and put that on the top, and we'll have to distribute the 2 in. So let's see what happens. If we, or I didn't want purple. I'm going to go back to green. Got to color code these, you know. If we FOIL the numerator, we have x squared minus 2x plus 3x minus 6. And then plus, if we distribute, we have 2x plus 2. So that's everything in that numerator combined. I FOILed and then I distributed. I didn't do any combining like terms yet, but I will. All over, our LCD is just all 3 of those parentheses, and you can write them in any order. We have an x plus 1, an x minus 1, and an x minus 2. Now, if we combine our like terms in this numerator, let's see what we have left over. I'm going to start with x squared, and that gets rid of this term. We have minus 2x plus 3x plus 2x. Well, the minus 2x and the plus 2x would cancel out. And that means we'd have plus 3x left over. And then negative 6 plus 2 would be minus 4. And that gets rid of those 2. Again, all over x plus 1, x minus 1, and x minus 2. All right, our next step, factor. Is it possible to factor this numerator, x squared plus 3x minus 4? Can you think of 2 numbers that multiply to get negative 4? We could do 1 and 4, or we could do 2 and 2. But they have to multiply to get negative 4 and add to get positive 3. If you thought x plus 4 and x minus 1, we're in good shape there. X plus 4 times x minus 1 would be the factored form of x squared plus 3x minus 4. All over x plus 1, x minus 1, and x minus 2. So we've factored the numerator. And then to see if we can reduce, let's see what we've got here. Do you see anything on the top and the bottom? That's an exact match. I can see these x minus 1s right away. That's not too shabby. We can take that. And then I think that's all we have. So we'll keep that x plus 4 in the numerator all over x plus 1 and x minus 2. There's our final answer for that addition problem. Take a look at this next example. We're still adding at least, but now we have 3 fractions. We have x plus 2 over x minus 4, and I'm going to go ahead and throw both of those in parentheses right away, plus 2 over x plus 5x over 3x minus 1, and I'm going to put that in parentheses as well. For factoring purposes, none of the denominators factor, so we're in good form there. So let's go ahead and state our domain. I just like putting it over here on the side, and then we're done with it. Just for the denominators, if x minus 4 can't equal 0, then x can't equal positive 4. We have x can't equal 0 in the middle, and then we have 3x minus 1 can't equal 0. If we add 1 and then divide by 3, we get a fraction. X can't equal 1/3. So there are our domain restrictions. We're good to go there. Step 2, state that least common denominator, that LCD. So notice we have one monomial, the x in the middle, and then 2 parentheses, 2 binomials. And none of them have anything in common. Do you see that? We've got our x, and then x minus 4 as a parenthesis is totally different than 3x minus 1. That means the LCD is the product of all 3 of them. So this is going to get a little tricky when we convert our fractions in step 4. So let's take a look at just one at a time. We'll start with our x plus 2 over x minus 4. But notice it still needs the x and the 3x minus 1. So I'm going to write that out, x and 3x minus 1, x and 3x minus 1. That's going to be fun to multiply. All right, let's try the second one. We have a 2 and an x. That one needs both of those binomials, the x minus 4 and the 3x minus 1. Put that on top and bottom. So we're going to have to FOIL that. And then the last one has 5x. Extend that fraction bar. It has the 3x minus 1. But it still needs the x and the x minus 4, x and x minus 4. Wow, we have our work cut out for us here. Let's take a look at that first term, x plus 2 times 3x minus 1. If I just distribute this x in, we get x squared plus 2x times 3x minus 1. Let's go ahead and FOIL that one right away. If I take x squared times 3x, I get 3x cubed. X squared times negative 1 would be negative x squared. Careful here, 2x times 3x would be 6x squared. And 2x times negative 1 is minus 2x. Combining those terms in the middle, we end up with 3x cubed plus 5x squared minus 2. X. There we go. All right, let's do the same thing for that second fraction. I want you to actually stop the video and see if you can do this product. I would actually suggest foiling first and then distribute the 2 in. Once you have that done, press play and we'll move on to that last example. Were you able to come up with 6x squared minus 26x plus 8? I hope so. When I FOILed x minus 4 and 3x minus 1, I ended up with 3x squared minus 1x minus 12x plus 4. And I combined like terms to get 3x squared minus 13x plus 4. But that 2 out in front means we have to double all of those parts. And that's what gave me 6x squared minus 26x plus 8. And then there's the last one. We've got 5x times x minus 4. If we multiply the outside parts together, that's just 5x squared. So that's not too bad. And then if we distribute that into the x minus 4, we would get 5x cubed minus 20x squared. So I'm going to drop that down here for that last term, 5x cubed minus 20x squared. Notice, everybody, this is just the numerator. We still have that denominator with all three parts. So this is all over. I'm going to put the x out in front, x minus 4, and 3x minus 1. What we need to do now is combine like terms. Now, if we do that, let's take a look at the x cubed. So we have 3x cubed and 5x cubed. That would give us 8x cubed. Cancels out that term and that one. We have 5x squared and 6x squared, and then minus 20x squared. That's a total of negative 9x squared. That gets rid of this term, this one, and this one. There's a negative 2x minus 26x for a total of minus 28x. And then our constant at the end would be plus 8. All over, wow, this is crazy, x times x minus 4 times 3x minus 1. Now, if you're wondering on how on earth are we going to factor that 8x cubed minus 9x squared minus 28x plus 8, here's a hint. It doesn't actually factor at all. Because of that, we can't reduce this fraction any further. Wow, that was quite a problem to solve. All right, we have one problem left, and that's subtraction. Find the difference of x plus 1 over x squared minus 6x minus 16 minus x plus 1 over x squared minus 6x plus 8. Again, let's put those numerators in parentheses, and just be careful here. They don't cancel out right away. Subtraction is tricky, so we have to make sure that we're watching all these steps. Of course, the first thing we want to do is simply factor the denominators. X squared minus 8 or minus 6x minus 16. Two numbers that multiply to get negative 16 but add to get negative 6 would be negative 8 and positive 2. There's x minus 8 and x plus 2. And then x squared plus 6x plus 8. Two numbers that multiply to get 8 but add to get positive 6 would be positive 2 and positive 4. Let's go ahead and state our domain restrictions right away. If x minus 8 can't equal 0, x can't equal positive 8. If x plus 2 can't equal 0, then x can't equal negative 2. And notice that happens twice, so we don't have to repeat that. But the last one, if x plus 4 can't equal 0, then x can't equal negative 4. All right, let's find that least common denominator. We have actually four sets of parentheses here. And we know that we have to at least represent them one time as many times as it occurs within each fraction. So I see that x minus 8, that has to be there. We have a matching x minus 2, but it's only written at most one time. So we only need it once in the LCD. And then we have that x plus 4. This is our LCD for this subtraction problem. And now let's convert. In the first fraction, I'm going to put x plus 1 in parentheses over, we have x minus 8 and x plus 2. But notice we're missing that x plus 4. If I put that in the denominator, I'm going to put that in the numerator, and we'll have to FOIL. And then minus, we had x plus 1 again, over x plus 2 and x plus 4. But we'll extend that a little bit further, but it's missing the x minus 8. Put that on the bottom and put that on the top. All right, two sets of FOIL here. Go ahead and do that for me if you would, please. FOIL the first two and FOIL, oh, that's an L, kind of got away from me there, and FOIL the second two. And then press play and we'll take it from there. Let's see how you did up to this point. When I FOILed the first two, I ended up with x squared plus 5x minus 4. Then that should be a plus 4. I did a typo there. All right, hopefully that's what you have instead. Okay, and then minus, but that second term, here's where we have to be particular because of the subtraction. If it's x squared minus 7x minus 8, but we're subtracting that, we actually have to distribute the subtraction to all three parts. And this is where, if we're not paying attention, that could really change our final outcome. So now we're going to have x squared plus 5x plus 4 minus x squared plus 7x plus 8 all over our LCD, x minus 8, x plus 2, and x plus 4. If we try to combine like terms, notice the x squareds cancel out. We have 5x and 7x, and that gives me 12x. And then we have 8 plus 4, which is also 12, all over our LCD. I'm going to run out of space here, so I'm going to move over just to the right a little bit to get a little bit more room. Now, we actually can factor a 12 out of the numerator, and that would give us x plus 1 left over. But notice, with all three denominators, that x plus 1 isn't going to reduce. And the 12 has nothing to reduce as well, so that would be our final answer for this subtraction problem. And that's the second half for lesson 8.5.